Welcome to the last module of the semester. Woohoo! Hopefully this module is going to be relatively a whole lot more simpler compared to what the last module was. Only in regards to, as long as you've got last module pretty much down pat, this one should be a breeze, okay? Because you're still going to be doing some factoring of equations, but we're going to do a few other things to go along with it. So first off, what we're doing in this module is solving quadratic equations. So the question is, what is a quadratic equation? It's simply this. Y equals ax squared plus bx plus c. This is a very simple quadratic equation. This is how you can tell. You see this right here is x to the second power. We have x to the 1 power, and then we just have nothing on this last piece. Long story short, your x will only go up to the second power. It will not go up any higher. And generally you have maybe about 3 terms like this, and it gets a little funny sometimes, but this is generally it. Ax squared plus bx plus c. And if you kind of remember anything from the last module, a lot of the equations that we were factoring were in that form. Now, what we're trying to do is solve for an equation. So there's 2 things that we can do. One, we can factor a quadratic equation, and 2 is use quadratic formula. Truth be told, using the quadratic formula, which is kind of like the most direct route of getting an answer for what we're going to be doing here soon. However, if you are really good at factoring can be a whole lot quicker than actually using the quadratic formula. And I'll show you what I mean here in just a moment. So let's go ahead and get right straight to the problems, and we'll talk about it. So the first problem I gave you is w squared minus 16 equals 0. And the first question you're probably saying is, how does this even look like this, which we know to be a quadratic equation? Well, let's rearrange this real quick. Let's say that this is equal to 0 equals w squared minus 16. Alright, so you don't have to do this on your paper. I just want to show you how this and this top part are the same thing. Well, we can go ahead and assume that the w means x. That makes sense. So think about it. This 0 is our y. That's easy enough. The w represents our x, and since there's a 1 here, that would be our a. So we can rewrite this so far to look like this. Make sense? But now look, I don't have a w by itself here. So like in this case, I have an x by itself. I could really say this, plus 0w. Where my 0 is my b and my w is the x. And then the minus 16, well that's easy, that's just my plus c. So I can really say plus negative 16. So really this equation is this same type of format, we just made it a little bit easier to understand. So I wanted you to see that. Now here's the thing. Knowing this will help us later on, but not right at the moment. Let's go back to the original question here. Our job is to solve for w. Alright, so your first instinct is probably like, oh, add 16 on both sides, blah, blah, blah. Stop. Think this through. We're going to use by factoring. What does this look like? Don't look at the 0, look at this guy. W squared minus 16. The w squared, hey, that's a perfect square. 16, hey, that's a perfect square. The minus, wait a minute, this is a 2-term. Hey, this is a special product rule. Remember that? So I can say that this is actually w plus 4 and w minus 4 equals 0. Now, what's happening here? There's a couple of fancy rules that we can say at this point in time, but it basically means this, that at any one point, this whole section could be 0 or this whole section could be 0. So we can actually rewrite this to say that w plus 4 is equal to 0. We can also say that w minus 4 is equal to 0. Now, see how I just kind of put this with that and this one also with that? So I've got 2 unique little mini equations here. So now I can solve for w. W is equal to negative 4 and W is equal to positive 4. All right, so I have two possible answers here. I have W is equal to negative 4, and I have W equals to 4. So the question you need to be asking yourself, which one's right? So what do we need to do? Well, we need to plug this answer back into our original equation right here. So if we plug in negative 4 in the place of this, negative 4 squared is 16, minus 16 equals 0. Does that work? Yes, that does work. Well, let's plug in regular 4. 4 squared equals 16, minus 16 equals 0. Does that work? Yes, it works as well. So that's the answer. So in both of these cases, when we solve for W, W is negative 4 and 4. And we can write it in a couple of different ways. We'll just go ahead and write it like this. Okay, so our answer for this is negative 4 and 4. So this next problem that I gave you is slightly different. It says that it's 16x squared equals 25. Now here's the thing, what you want to do is you want to get all your information basically on one side of the equation, and you want to get it into this type of format. Well, in order for us to do that, we already know that this is not going to have everything in this particular because B is going to be 0. So really all we're going to do is say 16x squared. We're going to subtract 25 from both sides equals 0. Now I want you to look at something. What did I just do here? Compare this, what I just did here, to the previous problem. What did I set it to? I set the entire expression is equal to 0. And that is the key thing when you are solving quadratic equations. You need to have everything on one side is equal to 0. That is your goal. So we're going to be continuing to do this. Now, let's look at this thing. So we've already said that our entire expression is now equal to 0, which is what we need. All right, so what are we going to do? Well, factor it. What is this? Hey, perfect square. Perfect square. This is a, difference of sums. So I can say 4x plus 4x plus 5 times 4x minus 5. If you don't know how I've got that, you need to go back and look at last module dealing with factoring, because this is a difference of squares. All right, now, what do? Well, like I said in the last question, basically we take each little chunk and set it equal to 0. So 4x plus 5 is equal to 0, and the other one is 4x minus 5 is equal to 0. Now we simply solve for x. 4x equals negative 5. X is equal to negative 5/4. Alright, next piece, do the same thing. We get 4x is equal to 5, and x is equal to 5/4. So the question you need to be asking yourself, which one of these is correct? So how do we go about doing that? Well, what we're going to do is we're going to plug each one of these back into our original equation. So I'm going to use my calculator because I'm lazy, and I'm going to get it out of my bag. And I'm going to plug in my calculator, and I'm going to say 16 times negative 5/4 squared. What do I get? I got 25. So that one worked. I'm going to do the same thing. I'm going to do 16 times 5 divided by 4 squared. Well, did that work? Yes. So our answers for this are negative 5/4 and 5/4.
Now, Mr. Lewis, why are we going to check it every time? Because it just works.
Yeah, that sounds like a very intuitive question. Why are we checking it? Here's a fact. When you get into higher order algebra, sometimes one of these will not work. Sometimes both of them don't work. Luckily for you, you probably won't see that much happening in this class. But still, before you give me this as your answer, you need to plug these back into the original question just to make sure it works. So let's keep trucking. Alright, so we now have x squared minus 13x plus 36. Our job again is to solve for x. We've already got everything nice and set up that this expression is equal to 0. So our job is to factor this thing. So how do we go about doing it? 1, check for GCF. Just like we did last module, check for GCF. No, there is no GCF. 2, check to see if this is a special product. Well, let's look at it. This is an x squared, so that's a perfect square. That's a perfect square. But does it follow my rule here in the middle? Well, the answer is no, it doesn't. Because if we actually went and worked this out, and I'm not going to do it all the time, it's going to give you a weird thing. So it's not going to work. So what we need to do is factor by grouping. Alright, so how do we go about doing that? We take the last term, multiply it by the first coefficient. Well, it's 36. What we need to do now is find all the possible factors of 36 that add up to, that when added will give us negative 13. So there are a few factors that we can do. Let's see what happens. Matter of fact, let's use our calculator. That's going to help us out. Remember the same thing? So we're going to go into y equals, we're going to clear out everything, and we are going to say that we want to do 36 divided by x, and we want to check out our table. If you don't remember how to do that, you need to go back in last module's videos. So let's see what we got. Oops. Alright, sorry about that. I had a little guffaw on the calculator. Alright, so what can we do to get negative 13? Well, that's not going to work. Negative 2, negative 18 won't work. Negative 3, negative 12 won't work. Hey, here we go. We have negative 4 times negative 9. That's 36. When I add those two together, I get 13. So I can say x squared minus, minus 4x minus 9x plus 36 is equal to 0. Notice what I just did. I put the 9 and the 6 together. Why? Just because I wanted to put them in together because they're both divisible by 3. I could have put the 4 there instead. It would have been fine too. Alright, solve by grouping. We're going to get x times x minus 4. And we're going to factor out the negative 9. Actually, you can factor out a negative 9 here. And that's going to give me x minus 4 again. What happens? This is still equal to 0. We don't need to forget that. Well, what's the same comes down, just like we're factoring, because we are. What doesn't, what's not together gets married. So now we have x minus 4 times x minus 9 equals 0. So now what can we do? Set each piece to equal 0. X minus 4 equals 0. X minus 9 equals 0. Solve for this. X is equal to 4. Solve for this. X is equal to 9. Alright, so we have 4 and we have 9. So it's quite possible that one, if not both of these work. So how do we prove it? Well, we plug it back into our calculator. We have 4 squared minus 13 times 4 plus 36. That gives me my 0. Cool, so we know that this one works. Now we're going to do 9 squared minus 13 times 9 plus 36, and that gives us our 0. So we know that this works. So we've double checked it with our calculator. So we know that the answer to this particular problem is 4 and 9. Alright, so I'm actually skipping question 4. I'm going to let you do that on your own in just a minute. And we're going to go right straight to 5 because this is the last one I want to talk about with factoring. So first off, before we can do anything, we need to hit this entire thing equal to 0. So what I'm going to basically do is I'm going to add 42 to both sides. And what we end up getting is 2x squared minus 20x plus 42 equals 0. Now, we know that in order to solve for x in this guy, we have to factor it. So, follow our rules. First off, is there a GCF in this? Yes, there is. This time we do have one. So I'm going to write 2 out to the side because we know 2 can get in all these things. And that's going to give me x squared minus 10x plus 21. 21 equals 0. Now, what is our job now? Well, we still have to continue to factor this guy. And so this is not a special product. We already know that because this last term is not a perfect square. We also, so by knowing that, we're going to probably do solve by grouping. Now, we're going to do 21 times that 1 gives me 21. So I need to find factors of 21 that when added together get me negative 10. So what are they? Again, we can use our calculator, but I've done this long enough, I already kind of know it. I can say 2 times x squared minus 7x minus 3x plus 21 is equal to 0. How do I know that? Well, 7 times 3, negative 7 times negative 3 gives me a positive 21. Add these two together, I get negative 10. Now I'm going to factor this out by grouping. Keep my 2, don't forget it. This is going to give me, I'll rewrite it like this. Okay, so we're going to factor out an x. I'm going to put a big parentheses right now because or a bracket. We're going to factor out an x. That's going to give me x minus 7. We're going to factor out a negative 3. That's going to give me x minus 7 equals 0. We're going to continue on. This is going to be x minus 7 because those two are the same. And what's left is the x to the minus 3, so they get married and we put a ring around them. So now we have 2 times x minus 7 times x minus 3. Now, there's been a kind of a step I've been forgetting to mention in the previous clips, but that's okay because I want to try to keep this video short. Double check. Foil this and we'll see if you can work all the way back up to the original equation. If you did, then we're good. Now in this case, I already know this to be the answer, so we're okay. So what do? Well, we're going to set each individual piece equal to 0. Look this out. We have 2 equals 0. We have x minus 7 equals 0. And x minus 3 equals 0. Well, think this through. Is this possible? Does 2 equal 0? No, it does not. So that really means nothing. All right, so it doesn't tell us anything. But what we can do is finish this out. We can say x is equal to 7 because we solved for this one. We solve for that and we get that x is equal to 3. All right, so which one of these is correct? Guess what? Double check. Plug these two individually back into it. So what we're going to do is going to get a calculator again, and I am going to say that we're going to start with a 7. Excuse me. Buttons are not working today. There we go. So we're going to say 2x or 2 times 7 squared minus 20 times 7. Hopefully if this works out, we should get negative 42. And we do. So now we're going to do the next one. We're going to try 3. Since we know 7 works, we'll try 3. And we're going to say 2 times 3 squared minus 20 times 3 gives us negative 42. And it works. So our answer for this, and I'm running out of space, happens to be 7 and 3. Well, let's put it in numerical order. 3 and 7. All right, so I've left problems 4 and 6 for you, so you know the drill. Pause the video, come back. Alright, so problem number 4, z squared plus 21 equals 10z. You should have got your final answer to be z is equal to 3 and 7. If you didn't get that, pause the video, check your work. Alright, for number 6, 4x squared minus 48x equals negative 140. When you worked all the way that out, you should have got the x is equal to 5 and 7. Again, if you did not get this, pause the video, check your work. For the sake of time, I think we've done enough with factoring by now. I think you understand this concept. Alright, so check your work. I told you that there were 2 possible ways of solving for a quadratic equation. First off is factoring. However, there's going to come a point in time that you may not be able to factor. And that happens because you get some weird numbers that just don't work. Even after you've done all the rules, you've done your GCF, you've done the special product, that didn't work. You tried to group it, but that doesn't work. And sometimes that happens. And the surefire way that you can solve a quadratic expression is using the quadratic formula. Can't talk. Let me get some Mountain Dew. Alright, so I went to Taco Bell earlier. Alright. Those beefy nacho grillers, awesome by the way. Alright, so what is the quadratic formula? Well, I always had a hard time remembering it until I was talking to my wife after we got married. My wife's a teacher too. Y'all may know that already, I don't know. And she started singing the song. Negative b, plus or minus square root, plus or minus square root. B squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a, and I never forgot that song. It's annoying. So, it goes, let's do it this way. X is equal to negative b, plus or minus square root b squared minus 4ac all over 2a, all over 2a. Alright, now, I hope that song sticks in your head and just burns your retinas and burns your ears. Well, anyway, not retinas, ears. Alright, so this is the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. It's hard for me to say that without singing the song. So let's cut to how we actually use it. So I've given you the equation of, whoops, that should be x squared, not x cubed. X squared minus 9x minus 36. You are trying to solve for x. So what we're going to do, we're going to pretend that we've done everything that we possibly can with factoring and all that, and this doesn't work. By the way, we can actually factor this particular problem. I just don't want to right now. We want to use quadratic formula. And so we need to figure out what goes where. Stuff from here has to come down here somehow. So go back to the beginning of this video, and I told you that quadratic formulas are always written in this type of format. Ax squared plus bx plus c. And it's usually like y equals, okay? Whatever. In this case, it's going to be c. So really, this is the format that I'm interested in. What is that telling me? It's telling me a couple of things. Well, first off, b. Well, what's b? In this case, it's the negative 9. Don't just say 9. It's a negative 9 because look, this is a positive. In order for this to be a negative, this has to be, or excuse me, a minus, that has to be negative. So we're going to plug in, every time we see b, we're going to plug in negative 9. Okay? Now, The next piece is A. So every time we see an A, we're going to actually plug in the number 1. Okay. And we do this one down here. And now we're going to plug in, every time we see C, which is just here, we'll plug in negative 36. All right, now we're going to solve this expression, this equation. And, well, negative times negative 9 is going to give me 9 plus or minus, we'll explain plus or minus here in a minute, square root of 81, because negative 9 squared is 81. Now we're going to multiply the negative 4 times the negative 36. And I've lost my calculator. Here we go. We have negative 4 times 36, and I get plus 144 all over 2. All right? So let's keep on trucking. This is going to give me 9 plus or minus square root of, let's see, 81 plus 144 gives me 225. We're going to square root it. And that's gives me 15 over 2. All right, so we've done all this. So far our answer is x is equal to 9 plus or minus 15. So what does it mean by the plus or minus? Well, hopefully you can kind of get it. It means plus or minus. So we can get 2 answers. All right. So I'm going to rewrite this up here as this. X is equal to 9 plus 15 divided by 2. And also x is equal to 9 minus 15 divided by 2. Now we just work it out. 9 plus 15 is 24. Divided by 2, we get x is equal to 12. Okay? Do the other one. 9 minus 15 is negative 6. Divided by 2, we get negative 3. So if we've done all our work correctly, our possible answers are 12 and negative 3. So how do we know this to be the case? Well, first off, we need to plug this back into our original equation. All right, so let's do it. We have 12 squared is equal to, 12 squared minus 9 times 12 minus 36, and that gives me 0. So we know that to work. Well, let's try the next one now. We have negative 3 squared minus 9 times negative 3 minus 36. And what do we get? We get 0 again. So that works. So our answer set for this is that x is equal to negative 3 and positive 12. This problem, x squared minus 2x minus 24. We are asked to solve this using quadratic formula. So let's do it. Negative b, that's going to be a negative 2, plus or minus square root, plus or minus square root, b squared minus 4ac, all over 2a, all over 2a. See, that works. Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, all over 2a. Alright, so enough of that song. Alright, so let's work it out. This is going to be a positive 2 plus or minus square root of 4 minus, that's going to be a plus 4 times 24. That gives me 56. Lost my calculator again. I keep moving it. 24 times, what did I say? 96? Yeah, 96. I think I said 56 a while ago. Anyway, 96 all over 2. This is going to give me 2 plus or minus, that's 110 over 2. So, my x can be equal to 2 plus 10 divided by 2. It can also be x is equal to 2 minus 10 divided by 2. Work this out. 2 plus 10 is 12 divided by 2. X is equal to 6. 2 minus 10 is negative 8. Divide that by 2. I get x is equal to negative 4. So we need to double check this. So 6 squared is 36. Minus 12, that gives me 24. Minus this 24, so that gives me 0. So that checks out. Negative 4 squared is 16. Negative 2 times negative 4 is 8, so add those together, that gives me 24. Subtract the 24, I get 0, so that works as well. So my answer is negative 4 and positive 6. Both of these work. Alright, so what I'm going to do now is I'm going to skip down to question 5 because I really want to show you that, and I'm going to leave 3 and 4 for you to do. Alright, so we have g squared is equal to 1 plus g times 5 minus 3g. Alright, so this doesn't look like anything we have done whatsoever. However, I told you before, what we want to do is to take this and get the expression equal to 0. So really what we're getting ready to do is basically simplify this thing, and then we'll go from there. Alright, so let's do this. G squared is equal to 1 plus, well, what's g times 5? 5g. G times negative 3g is negative 3g squared. Alright, so let's keep trucking. What our job now is to get everything on one side of the equation so that it's set to 0. I'm going to add 3g to both sides, and that's going to give me 4g squared is equal to 1 plus 5g. Now I'm going to subtract this from both sides, and I'm going to get 4g squared minus 5g minus 1 is equal to 0. That is what we have done. So we have taken this entire first equation and rewrote it in a format that we're more used to. So I'm going to erase the board, and we're going to start with just this equation, and we'll do the next part. So I rewrote this equation right here, 4g squared minus 5g minus 1, just like we had in the last clip. I am keeping the original equation up here because we are going to need it again when we go check our answer. So, quadratic formula. Alright, let's do it. Negative b, plus or minus square root, b squared minus 4ac all over 2a. Alright, so that's going to be a negative 5 in the place of b's. I'm going to have a 4 in place of my a's. I'm going to have a negative 1 in the place of my c's. Now I'm going to solve. This is going to give me a positive 5 plus or minus. That's 25. 4 times 4 is 16. That's going to give me a plus 16 all over 8. Alright, so let's see what we have. 25 plus 16 gives me 5 plus or minus the square root of 41 all over 8. Alright, so can 41 be factored? Is there any perfect squares in 41? Let's see. 1 won't work, too little. 4 won't work. 9 won't work. No. So really, guess what, guys? This is kind of as far as we can take it. I mean, and this happens from time to time. You get an answer that you can't take it any farther. Now, we can plug this stuff into our calculator and to see what happens. So what we're going to do first is we're going to do x is equal to 5 plus the square root of 41 divided by 8. So that's one answer. And the other answer is 5 minus the square root of 41 divided by 8. So the question is, how do I take those two answers and put it back into our original equation? Well, go back to last module again. I showed you a neat, handy thing to do on your calculator, and that was the store button. So what we're going to do is we're going to put this into our calculator. We're going to say the square root of 41, and we're going to add 5, and then we're going to divide that by 8. So your calculator should say something like 1.42 blah, 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 blah. Well, we want to store that number. So we're going to say store x, just like we did in the previous module. And now what we're going to do is plug that x in the place of g. So let's do this. We're going to say 1 plus x, do your parentheses, 5 minus 3x, and close your parentheses. So I want you to see exactly what I've done. I'm going to get up on the camera here. So, you see what I've done? I've done 1 plus x times 5 minus 3x. And that x is that 5 plus square root of 41 all divided by 8. So I'm going to hit enter. And I've got this weird looking number. Now my next thing is, notice that I'm trying to do the first one. So I've already done one side of the equation. Now I need to find out what g squared is. And that's kind of creepy. You're seeing that one eye. I need to see what x squared is. Do you see my eye? Ooh, bloodshot. All right, so we're going to put in x squared. Just like that. And if we are lucky, they should be equal. See what happened here? Is that first thing, that's the one side of the equation. It's equal to the other side of the equation. So what did that just tell me? It told me that this guy is a correct answer. Now we're going to do the same thing with this one. I'm going to put the square root of 41, and I'm going to say 5 minus that square root of 41, divide that by 8. And I get negative 0.17 blah, blah, blah. So I'm going to store that as my x. And we're going to do the same thing again. And what we'll do is we're going to say 1 plus x times 5 minus 3x. Just like that. Okay, because we've already stored that x. Hit enter. And then we're going to plug in x squared. And when we do, we notice that both sides of the equation are equal. So what does that tell us? It tells us that this is also correct. So our answer set is 5 minus the square root of 41 divided by 8, and 5 plus the square root of 41 divided by 8. So that is our correct answer. Now this may not seem very useful to you now, but when we actually start graphing equations, this is going to work fantastic. So I want you to, you know the drill, on questions 3 and questions 4, try them on your own, pause the video, blah, 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 and come check your answer. Alright, number 3, x squared equals 5x plus 11. Your job is to get it equal to 0. So you should have rewritten x squared minus 5x minus 11 equals 0. Then do the quadratic formula song, plug in your values. You should have got that x is equal to 5 minus the square root of 69 divided by 2. And 5 equals, 5 plus the square root of 69 divided by 2. Check both of these out like we did here. Use your handy dandy calculator function called store and plug it back into the original equation. And did it work? Yes, it did. So if you didn't get this right, check what my work and see where you went wrong. In this problem, 4x squared plus 17x equals negative 15. Set it equal to 0 by adding 15 to both sides. Do your magical, wonderful song and work it all the way out. When you do, you would have got negative 17 plus or minus 49 over 8. And that breaks down to two different parts. So it says x can be equal to negative 17 minus 7. No, because square root of 49 is 7. Over 8, or x is equal to negative 17 plus 7 divided by 8. Solve both things, and you find out that x could either be negative 3, or x could be negative 5/4. So before just writing that answer down, store function and check it out to see if it works in the original equation, and they both did. And your answer is that x can be -3 and -5/4. Now, that's the first video done. You have an extra credit question, you know the drill. Bring that to me on the day that these notes are due, and I will see you in the next video.